the plan is to run this presentation. It's around 35 minutes. And the focus is, of course, a lot of, USB-C, and it might be a bit on the, techie side, but, it's a good basis to first go through the standards here of USB-C. And then in the context then of having USB-C in the Pro AV environments, right? So video conference rooms and so on. Yes. So if we jump into the USB-C standard as a whole, I mean, as you know, the cable, USB-C cable, is the one that provides you with video, USB communication to USB devices, and charging. The term USB-C, it's kind of a shortened version of USB Type-C, with Type-C being the connector. You have basically Type A and Type B. That is the old two USB connector types. So Type-C being the third one. But to make it a bit easier to say, usually just say USB-C. And so to take sort of a step into how USB-C works then, we can look at what it actually includes. So when the standard originally is, behind USB, you have companies like Intel, HP, Microsoft, and with USB-C, also Google and Android joining into it, and a couple of other companies. And of course, the requirement was to try to get all the different functions in the single cable. And when they sort of invented USB-C, they still had the existing different protocols that are used. And so you basically took all those protocols and sort of different cables and more or less put them in a single cable. So, and then there was the invention of the power delivery protocol, which was the new sort of addition, which is the protocol that is used to allow the laptop in this case, and for instance, USB-C dock, to communicate with each other, and between them decide how to deal with all the other different functions in the cable. So because of that, you basically crammed a couple of different protocols together in a single cable, plus added charging. Everything became a bit complicated from a technological point of view. From a user point of view, at the end of the day, it's just one cable and it's easy and it's small, so it's easy to use. But from a technical side of view, it becomes, of course, a bit more complicated because you took all these different functions and put in a single cable. And to understand a bit more how it works on a high level, this picture here shows a bit how the different protocols are handled in a typical, video conferencing room. So on the left there, you have the laptop, you have the USB-C cable. You then have different protocols running, and we can take a look at those here. So the red one here are normally the video protocol, which is using a standard called DisplayPort. So video goes over DisplayPort in the cable. It then enters if you take the docking station here, for instance, and then often it's converted to HDMI. And then it goes HDMI to the TV or the display, for instance. The blue lanes here represents the USB protocol. So USB protocol, the thick one here is USB 3. It usually goes to a hub or several in the device, and then it continues into a USB 3 device. In parallel to the USB 3, you also have the USB 2 protocol and wires. It runs USB 2 from the laptop to a hub and then potentially into USB 2 devices. And here it's good to note that when we talk about USB 2 and USB 3, they are basically 100% different protocols. So even if the hub that you have in between is USB 3 hub, it's basically hubs, you can say, one USB 2 hub and one USB 3 hub put in a single product. So when you always talk USB 3 from a laptop to a device, and you talk USB 2 from a laptop to a device, you never go USB 2 halfway to the hub and then change to USB 3 or the other way around. So always when you do wiring, there is always the requirement to have, if you have a device that can only do USB 2, you have to have USB 2 all the way to the device. If you have a device that can only do USB 3, which is basically very uncommon, you have to have USB 3 all the way. But it's important when you do cabling to ensure that you have the full capability all the way through the system. Then there is the charging. And we'll come back to that a bit later, but charging is, of course, a separate cable, and the power delivery protocol that I mentioned is to a large extent then taking care of setting up the charging and the power flow in cable. What also makes the whole thing a bit complicated is the versioning, and USB is consistently complicated to deal with versions. And a problem is, again, that a bit of a background here. So the USB IF, that is the Implementers Forum, the standardization body for USB, they standardize the USB 2 and 3 protocol and the Type-C standard, how to put everything together. They don't standardize DisplayPort because that's done by VESA. They don't standardize HDMI. So when you make a USB-C cable and you put the standard on it, it doesn't really define, for instance, which DisplayPort you can run it and so on. And often when you see terms like USB 3 and USB 4, that actually only defines the standard for the USB protocol, not for the entire system here, because that's the Type-C standard. So when you see terms like USB 3.2 Gen 1, that actually means 5 gigabit USB, and then you have USB 3.2 Gen 2, that's 10 gigabits, and then you have USB 4, which is actually an open version of Thunderbolt, which is a completely different thing. So in general, it's a bit hard to understand it. Then on the down left side, we have something called SPR, which is the charging profile up to 100 watt, and the extender power roll, which is charging up to 240 watt. So all these standards basically are separate, and also they evolve, independently of each other. So, which means that it's also a bit hard to understand, if a product or laptop support this or that, or a cable support this or that. But again, the underlying issue behind that is that we have all these different separate standards that evolves a bit independently, and then they're sort of into the same cable. There are more detailed explanation on these, but we'll keep it a bit. We're just going to say it's complicated for now. One thing which is important, though, in our world specifically, is the video over USB-C. And there are, in principle, 3, for practical purposes, ways to do this. The native function, if you call it like that, which is defined in the standard as well, and it's implemented by most devices on the left, is the DisplayPort standard, and that is called DisplayPort Alt Mode, or DP Alt Mode. Alt Mode means alternate mode, and alternate mode is a feature in the USB-C standard to decide what high-speed protocol to run on the cable. So basically, you have the DP Alt Mode function. It means that the laptop's going to send video in DisplayPort format over the USB-C cable. It can then be converted to HDMI, for instance, somewhere along the line, which is pretty simple method to do because DisplayPort has a built-in feature how to do HDMI conversion. Then there is the Thunderbolt protocol, and nowadays, and a bit of a sidestep there. So Thunderbolt is a different type of protocol to combine the USB and DisplayPort and PCIe, which was invented before USB-C. So it's kind of intended to do the same thing as USB-C, but in a bit more complicated, but more flexible manner. And then Intel open sourced, you might say, Thunderbolt and called it, and in USB standard, Thunderbolt is USB 4. So USB 4 is not just an extension of USB 3, it's actually the old Thunderbolt protocol. And now when you see that flash, that means that it's a device that implements all the features basically of USB 4, and then it basically complies to the Thunderbolt profile instead. So devices which are not certified by Intel, they can still have USB 4. But when you get the Thunderbolt logo, it means that you have been certified by Intel, plus that you have implemented all the required features of USB 4. Anyhow, so then you run video over Thunderbolt and you change that, for instance, into HDMI. So here you need a docking station, for instance, that supports USB 4 or Thunderbolt. Then there is DisplayLink, which is a proprietary protocol. It's not really standard. It's basically a software solution. You run a small client in the laptop, which takes your video output and puts it over USB 3, runs it into a DisplayLink to HDMI docking station, for instance, and then out to HDMI. So this one doesn't require USB-C per se. You can run it over sort of the old USB-A connector. Problem is that it requires drivers to be installed. They are somewhat easier to deal on Windows if you don't have locked down your laptop, sort of corporate security. But on MacBooks, it's a bit of a very complicated for the end user. So DisplayLink with USB-C, kind of the need for DisplayLink has slowly eroded a bit, so we don't see that so much anymore. So again, and also laptops which supports Thunderbolt or USB 4, they always support DisplayPort as well. Whereas a device that supports Thunderbolt doesn't necessarily support DP Alt mode, and not all laptops supports Thunderbolt. So it's always much more a high likelihood that everything works if you stay on DP Alt mode in a video conference room. Okay, so let's look in a couple of different areas then and how they kind of issues that pops up in usually then the video conference room. So if we look at charging then, so how charging works is that first of all, the charger or the device providing power announces what kind of power profile it supports. It can be 60, 100 watts, 140, up to 240 watts. And the way this is done up to 100 watt is that it's a 20 volt charging level up to 5 amp. So that's 100 watt. There is the 60 watt step is done by doing 20 volt and 3 amp. The laptop asks the charger what profile it supports, and then the laptop, power profile that is suitable for it. Then there is the cable as well in between, and the cable, if the cable needs to supports more than 60 watt, it has a marker which indicates 100 watt or 140 watt and so on. So the laptop also looks at the cable. The laptop looks at the cable's capability. The laptop looks at the docking station capability, and then select the most suitable or the highest possible watt. The one thing is to know. So there's a reason for why not all cables are 100, 140 watt is usually the voltage drop. So if you have a long cable, high current, the voltage always drops in the cable. And the voltage is only allowed to be dropping by 5%. So for 20 volt output, it's 19 volts. So if the voltage goes down below 19 volt, the laptop might restart the charging. So if you want to have longer cable than 2 meters, for instance, this becomes a bigger issue. And even at 2 meters, you need cables that are. But when they mark a cable that's 100 watt, they have to ensure that they have enough sort of copper in the cable to deal with it. The new standard EPR MacBook Pro is a good Pro Max, one example of laptops which implement the 28 volt level, 140 watt charging. More and more workstations coming out with that, and this is very good because before workstations from HP, Lenovo, and so on, they have their proprietary ways to push over the 100 watt limit, and now this is a standardized way. So that's great for all high-end laptops. little bit early days. HP, Lenovo, Dell have lab models out now basically that have moved to this standard, but very still early days outside of the Apple ecosystem, you might say. Yeah, and as I mentioned, common issues. I mean, we see lots of cable on the market which actually are marked as 100 watt, but they actually have too large voltage drop. So I mean, you don't actually have to certify a cable officially. You can just say it supports 100 watt. And unfortunately, we see many examples of this. And the effect of this is typically that you connect the laptop, it works, but after like 2 minutes, when the battery has ramped up its charging, then the voltage drops because higher and higher, and then it gets too high, and then the laptop restarts charging. What the users see is video going up and down, actually, because they don't see that the charging stops and starts very rapidly, but the video goes up and down. So that's good to keep track of. Yeah, it's just good to say that you cannot really have a solution that supports if the docking station provides 60-watt charging, and you have very long cable, you cannot tell the system to don't charge at all, because you cannot charge with less than 60 watt if the source provides 60 watt. So you cannot have a cable which says like this is a 20-watt cable. Yes, and then again, laptops that have their own proprietary solution from before to push over 100 watt, like Dell, for instance, a bit complicated there. Yes. Okay, so if you look at video, this is of course also an area that complications can happen. And so the solution here is that the laptop sets up the DisplayPort connection to the device, the docking station or the USB-C device. So it's going to establish the DisplayPort channel. Then everything moves into DisplayPort world. And then the DisplayPort going to communicate, and the communication between the device and the TV is somewhat transparent because it's the same protocol, the AUX and DCC protocol that goes all the way. So the laptop is then over DisplayPort/HDMI asking the TV, hello TV, what resolutions do you support? And then select the highest possible resolution from that. So what is a bit interesting here is that when you set up the video, the DisplayPort lanes in the USB-C cable, you usually allocate 2 high-speed lanes to DisplayPort and 2 high-speed lanes to USB 3. Those 2 lanes of DisplayPort defines the available bandwidth for DisplayPort. So normally in a new laptop, that's 2 lanes, each at 8.1 gigabit, what is called HBR3. So the laptop will then have 16 gigabit of bandwidth, available bandwidth for video. Then if you have HDMI 2.0 on the other hand, you have 18 gigabit there, so that's fine. You can run all your resolutions, which is up to dual screen 4K 60 Hz with max compression and so on. You can also allocate 4 lanes of DP in the USB-C side of things, and then you can run twice that resolution. But then you don't get access to USB 3. But this is a bit special case, not so often used. What is a bit the usual problematic thing that happens in this flow is that the HDMI channel doesn't support full HDMI 2.0. It could be an extender only doing HDMI 1.4. It could be a long HDMI cable more than 7 meters, and then HDMI 2.0 bandwidth becomes a bit, on the edge. The problem when you normally insert an HDMI cable directly into a laptop, there is a built-in feature in HDMI that downgrades it does a signal training to test the capability of the solution, and then the laptop selects a resolution that it can safely run over the HDMI cable. That negotiation doesn't really work when you do this conversion, where you do first DisplayPort, then converter, then HDMI, which means that the decision about resolution is done without the system knowing the capability of the HDMI link. So if you have an HDMI 1.4 solution there, and your TV supports 4K 60 Hz RGB or 444 color space, meaning you're up in the 15-16 gigabit range, the laptop will select that resolution, even though the HDMI solution only does 9 gigabit of HDMI signal. And then typically you get lost picture, flicker, dots, stuff like that. And it might be so that another laptop doesn't have that capability to deliver full video over the USB-C port. So for that laptop, it works very well. But when you come with your MacBook, which can cram out maximum bandwidth always, basically, you can get issues on these kind of things. So it has to be an HDMI 2.0 capable link. Very important. There are also EDID issues for various reasons here. Usually that the top of the video between the laptop and the docking station and setting of the charging interrupts the EDID communication. So that laptop will not get the correct EDID or no EDID and these kind of things. And then you can get like a green picture or a tinted picture or no picture or, very low resolution, for instance. So that can be many issues there as well. Usually EDID emulation will solve most of these issues if it's not possible to sort of change it on the TV side, or in some solutions like Ochno, you can work with the timing of the setup in the dock there. And there are also just a couple of pure bad implementation of laptops, actually, how they implement USB-C, which is basically resulting in failure. But yeah, that's another thing we are working a lot with. Yes. So the other part, and if we talk about the USB protocol then. So again, you connect your laptop. The laptop will set up a USB 3 communication to the dock. The laptop will set up a USB 2 communication to that internal hub. And then you have your camera, your speakers, your microphones, etc. in your conference room connected to USB as well. So what happens here is that, so if you have a device, it can do both USB 3 and USB 2. You have cabling to it, USB 3 and 2 cable. You have a USB-C cable, it has the USB 3 and USB 2. So then the laptop is going to see the device on USB 3 and it will connect on USB 3. If the device in question is just connected through USB 2 cable, it will make an end-to-end connection all the way from the laptop to that device over USB 2. There are all these separate connections between the laptop and the different USB devices that you have. And of course, USB 3 is very good to have if you have cameras. They are the ones that benefits from USB 3. So for speaker and audio, or microphone, there are basically no benefit of running USB 3. But for cameras, there are definitely features. And you also have different, more advanced, AI tracking, these kind of features, which also rely more on the USB 3 functionality, which are then downgraded or lost altogether if you don't have USB 3 capable communication between the camera and the laptop. Then there is the sort of bane of USB in video conferencing room, and that's the max amount of hubs that can be used between the device and the laptop. So when Intel and the companies invented USB, they thought that, on my desk, I have my laptop, I have my dock, I have my mouse. How many hubs do you have there in between? 1 or 2 maybe. So they thought that, okay, if we say max 5, that's, a lot. So that will never be too little. But in a video conferencing room with very long and complicated cabling, it's starting to become an issue. Plus the fact that Apple in the M series made the decision to include a hub in the laptop, and that hub counts as a external hub actually. So you have something called root hubs, which are those that sit in the laptop, and they are not usually counted towards those 5 hubs. But in Apple case, with their own M processor, the internal hub is not a root hub. But it actually was a root hub in the beginning, and then after the software update, it became not a root hub anymore. So you only have 4 hubs if you want to make a room which is MacBook M series compatible. And then everything that you put in between your laptop and the device usually have various hubs in it. So a docking station, 1 to 2 hubs is the norm. If you have like HDBaseT extenders or other extender technologies, they also have a different number of hubs. Active cables have lots of hubs, usually every 5 meter, in different forms. Optical cables often have hubs as well, in 1 or 2 in each connector. Interactive TVs, they are usually a mess of hubs because of how the interactive TVs are constructed with different internal PCs and so on. So it could be up to 3 hubs actually in some worst case to reach the touch function, to be clear, right? So to connect to the TV and then get access to the touch function, it can sit behind many hubs. Lots of devices that you think is just a pure camera also have internal hubs actually for no particular reason, which is a bit annoying. So this kind of calculation about the number of hubs is super important actually nowadays. And there is also there is a tool called USB Device Tree Viewer. All of you out there installing stuff and don't understand why it doesn't work with USB, that is the tool to use. So a typical example is that, you have a Windows machine, you can access the camera. For instance, you have the Mac, you don't get access to the camera. That's one case can be that you have too many hubs in the system, or that the touch function on the screen doesn't work on the MacBook or stuff like that. Also, sometimes you have a situation where you only have a cable on one side, which supports maybe only USB 2. And then you might have like an optical cable on one side that only do USB 3. So in that case, there is zero possibility to have a communication because you cannot convert from USB 2 to USB 3 in the hub. It has to be either USB 2 communication all the way between a laptop and a certain device, and USB 3 from a laptop to another device. So that is a kind of a common USB thing there. So long cables that's actually, we have a separate session just on extension, but to give you a bit of a teaser then on this one. So there are a couple of different technologies that can be used. We have active cables, we have HDBaseT, for instance, we have optical, usually called active optical cable, AOC. And the challenge when you do long cabling on USB-C, then the actual extension technology has to extend the different internal protocols using different means, which is why it becomes a bit complicated to make long USB-C cables. What we can say in general of USB-C cables is that for passive USB-C cables, it's always the protocol with the shortest distance that defines the max length of the cable, basically. And since USB 2 protocol can do 5 meter, it's 2 there, sorry. So USB 2 protocol can do 5 meter passive according to standard. USB 3 can do 3 meter passive, and DisplayPort can do 2 meter passive. Since the USB-C cable have all this protocol, it's the DisplayPort's 2 meter that defines the max length of a passive USB-C cable. So regardless of how much copper you put in the cable or how good, quote, cables you put in there, 2 meter is the standardized maximum. And often it works with longer cable because because there are redrivers and retimers in the laptop and the docking station that fix the signal, but that is not the required functionality. So if you are just barely compliant on the laptop on the dock and you have a cable which is longer than 2 meters, that it's a high likelihood that it will get lost packages. So 2 meter passive USB-C is always our recommendation to the maximum. If you go longer than 2 meters, it has to be different forms of active technologies, and also keeping track of the charging power. On the right side of things, for if you use HDBaseT then to extend on the right side, ensure that it's HDBaseT 3, because HDBaseT only do version 2 only do HDMI 1.4, so not enough in this case. And again, if you use cables, passive cables, I mean 6, max 7 meter to have robust HDMI 2.0, signal over copper cable. AUC, we always recommend to not connect directly to laptops. So only using between one device and another device, not to laptop, because as soon as you involve the laptops, there is like a ton of potential issues that can happen with charging and compatibility and broken cables and broken laptops and stuff like that. So this is a bit complicated. But we have as I said, there is not planned yet, but we have for the future another session as well that we might run here also for extension of USB-C in general. But to sort of summarize a bit in terms of what to think about when you make a room then. So always try to keep the USB-C cable short. So that is there is often, it feels in some cases you have rooms where it would make sense to have sort of just a long USB-C cable that goes maybe on the floor and up on the table or hangs on the wall and you pull it out and these kind of things. But you always add a lot of troubles to yourself if you want to make the USB-C cables too long. So a more robust solution is always to sort of terminate the USB-C, somewhere, the copper, and have a short copper cable, the last distance. And yeah, there are options that Ochno and others are using to make this in a smart way. Another thing that we, of course, this is a bit Ochno USB here, but laptops and firmware in laptops tends to change a lot over the years, and dealing with the firmware on the receiving side to adopt those changes has been proven invaluable, because there is so many strange things happen in laptop implementations and OS devices. So, and when everyone else is updating the firmware in the systems on the left and right side, it unfortunately becomes important that this thing in the middle can also update its firmware to work around different issues that pops up usually in combinations of specific devices with specific laptops, which also points to the final one. It's of course always recommended to use combinations, when you combine devices, cable lengths, laptops, TVs, and so on, to use solution that has been validated by someone else. And usually it's the part in the middle there that has to do the validation towards the left devices and the right devices and the left laptops, which is something we at Ochno is spending a lot of time on. Yes. So to wrap up then, a couple of takeaways. USB-C is the future. It might sound like everything is very complicated, which it is. But on the other hand, it is actually, there is no other standard around the corner. I don't see it and no one else sees it, and everyone is working on the next and future versions coming out for USB-C. Still, USB-C connector is there. So what happens is that the internal protocols are continuously upgraded. So it's USB 3, it's USB 4, it's USB 4.2, it's USB 4.2 Gen 2, etc., etc. But the connector is still there, and the internal protocol is upgraded step by step. So, and there is no wireless standard coming out that's going to solve everything wireless, unfortunately. So cable is the future for now. And for that, it's USB-C. And it helps you because often you have this, multi-vendor installations, right? And to add functionality to what the device in the first place doesn't have, the main device that you have, if you have a video bar and you want, a long USB-C cable, etc., how to deal with that. It's always good to have someone that has tested and ensure that this works, of course. AV versus consumer IT. So this is a bit, vague term, of course, but for products that are designed to be sitting on a desk. Maybe not consumer IT, but also for desktop IT, we might call it. They have been tested and optimized for that environment, whereas in a conference room, there are especially the long cabling and the sort of long USB chains and the fact that you use complicated and big TVs instead of monitors and so on. These things, are slightly, even if the same standard, there are still ifs and buts there, which makes it hard sometimes to reuse products intended for the desktop, for instance, into the conference room. And then monitoring and software management, of course, once some system in the chain, the laptop, the video bar, etc., the MTR system, when they start, since they have support for firmware updates and they do a lot of firmware updates, it basically forces all the other systems to do firmware updates. So if no one had done any firmware updates, if the laptop and Windows didn't change, if the MTR system didn't change, then you wouldn't have to change anything in between either. But as soon as someone starts to change all the time, update software, everyone else are basically forced to do it as well because there are changes introduced in the system. So we are where we are right now, which is kind of a firmware update, rat race. But that's life. Yes. So with those kind of introductory words about USB-C, any thoughts and questions